Hey, what's happening, people? We are on page 198. Mr. Knoll was way off. He had no idea what page we're on. Anyway, we're on page 198. Here we go, qualitative graphs. Now we're doing a little bit more with them, not just talking about increasing, decreasing, that sort of thing. Okay, first question. How does the sketch of a graph of a function help describe its behavior? So I will say, guys, it shows the relationship between what? Between the two quantities, right? So it'll show us the relationship between whatever our x and our y variable or quantity is. They say input and output a lot in this section. So again, that we should be familiar and comfortable using both of those words. But it just shows me that relationship again. That relationship can be doing one of three things, right? It could be increasing, decreasing, or staying the same. We call that constant. Okay? Hey, that didn't go away. All right. How do you know which variable goes with which axis when you graph it? Well, we put the input variable where? Input goes on the x-axis. All right. That means the output will be on the y-axis. Okay. Eventually there's this little silly saying that I say y depends on x because y is the dependent variable and x is the independent variable. Ms. Lindsay will probably get into that at some point in time this year in science class. If you write that down and remember that and tell her that, you probably get some kind of bonus, or she'll think you're just awesome. So anyway, y depends on x. So the dependent variable always goes on the y-axis, and the independent variable always goes on our x-axis. How can you determine the shape of a graph? Well, the shape, guys, comes from that relationship, right? So once again, the shape can be increasing, right? Or it could be decreasing, or it could be constant. It just depends, right, which one of those three things we're going to do based off of what our graph is doing, okay? All right. Yes, trees. Here we go. Class plants a tree. Sketch the graph of the height of the tree over time. Okay, so let's analyze this. At year 0, tree's already 3 feet tall. Year number 3, now our tree is 7 feet tall. That means it's taller than me. Identify the two variables. Well, time is one variable, height is the other. Okay? So time and height. I know, you want to know which variable goes where. Well, think about it this way. Remember that y depends on x thing? Guys, does the time depend on the height? Or does the height of the tree depend on the time? Yeah, that one makes sense. That's how you know height is the y variable or dependent variable, and x or time is the x or the independent variable. Okay? So if we're going to sketch that graph, guys, think about it. As time increases, what's happening to the height of our little tree here? Well, it's increasing as well. Now, should we start here at 0 and go that way? No, why don't we want to start at 0? Right? Remember, label your graph, guys. This is time. This is height. Okay? Well, at a time of 0 years, our tree was what, 3 feet tall? Okay? And then as 3 years went by, it had a height of 7. Right? So I think it's probably going to go through that point right there. Okay? Again, we're assuming it's growing at a constant rate those first couple of years. Maybe a tree does, maybe it doesn't. Who's to say? Maybe it grows faster when it's younger and slower when it gets older. Okay? Either way, we don't have to worry about that. I think that's a great looking graph. Last one here, number 5. Again, sketching graphs. We're going to do lots of sketching, so you're going to get better at this. An airplane takes 15 minutes to reach its cruising altitude. Okay? All right? The plane then cruises at that altitude for 90 minutes. All right, then it descends for 20 minutes before it lands. Right? Sketch that graph. Well, I've conveniently drawn rectangles around my 3 intervals. Okay? So this is the first thing I need to do. If I'm given, right, a paragraph, this isn't really a paragraph, if I'm given a few sentences, okay, and I have to sketch this graph, right, read through it and figure out how many intervals we're going to have, right? This one's going to have 3. In my first interval, which it takes 15 minutes for the plane to reach its cruising altitude. So we have to think about the relationship between altitude and time. Well, the first 15 minutes, people, the altitude is increasing. So we're going to start here, and for 15 minutes, we're increasing, right? Then we are going to fly at that altitude for 90 minutes. Well, guys, if this was 15 minutes, 90 minutes it's got to be a lot longer. Okay, a lot longer. All right, look, there's about how long that one was. So yeah, this one that seems about right. And then the last interval, we're going to descend for 20 minutes. So again, it's going to be about that same length. I need my graph to go a little bit longer here. Okay? About like that. Again, if you have roughly that shape, we're not looking for super exact, we all want to have the same one. That's what's kind of nice about these. If you've got the general shape being, hey, the first and the last interval are roughly the same. The last one needs to be just a smidge longer, right? And then this main interval, that second interval, right, needs to be a lot longer, right? What we wouldn't want, guys, is for you to have this here, right? That is not the same. While it has the same shape, that shows me really all 3 of those intervals are the same length of time, and that's not true because it's giving me 15 minutes, 90 minutes, and 20 minutes here, okay? So when they give us those numbers, we kind of got to use them a little bit. So guys, that was our key concepts on page 198. We're going to now flip to the packet. We're going to do the additional practice. Again, more practice of qualitative graphs. All right, I'll see you there.